So, hi everyone. This is the first time when I actually have to hold a microphone, so it's gonna be weird. Yes, so today my session is about Typescript metadata. I'm gonna talk about dependency injection in Nest and Angular, and being honest, this talk is slightly complex, so it's gonna be interesting, I hope so. So before we dive into this topic, let me quickly introduce myself. I had a great introduction, so real quick, my name is Kamil. I'm a co-founder of Trillion.io, the next level software consulting company, and I'm a full-stack software engineer primarily focused on the web-related things. I've also recently became a Google developer expert in web technologies and Angular. Thank you. You can find me on Twitter using this highlighted blue Twitter handle and obviously on the GitHub. Beyond regular day-to-day work, I'm giving the value back to the community as an open source contributor. I'm the creator of NestJS, which is basically the fastest growing, the fastest rising Node.js framework in 2018. In the last year, we have noted almost 300% growth in the number of GitHub stars, leaving behind any other existing Node.js HTTP library, including all those famous ones like Express, Koa, or Happy.js. Like, I think that everyone recognizes all those libraries, which is awesome. Regarding NestJS, maybe before we dive into this topic, let me quickly ask you a question. Who has heard about NestJS? Please raise your hand. All right, something like 20, maybe 30% of the audience, which is awesome. Who is using NestJS already? Oh, a little bit less, okay. 10%, okay. So just to ensure that everyone is on the same page, NestJS is a framework. It's a framework entirely written in TypeScript and is heavily inspired by Angular, taking what's best in Angular and reflecting it in the Node.js ecosystem to allow people building a wide range of server-side applications in a similar way, in a similar fashion as in Angular. But today, I'm not going to talk about NestJS exclusively. If you're interested in things like exclusive things about NestJS, you can visit the website, nestjs.com, or you can follow the Twitter handle in order to stay updated with every following release and every backfix. The Twitter handle is Nest Framework. So today, instead of talking about NestJS, I'm going to dive into the feature that overlaps between frameworks, that overlaps between Angular and Nest, called Dependency Injection. And Dependency Injection is an important application design pattern. It helps us creating flexible, scalable, and maintainable systems. And both Angular and Nest have their own dependency injection systems behind. Let's consider this simple example. So we have a cat service. This is a class, injectable class, that makes use of two different dependencies, respectively HTTP service and logger. Both are immediately instantiated within the body of the class, which means that every time when we create an instance of the cat service, we'll actually create an instance of both HTTP service and logger as well. And we already know that this approach is not very maintainable, it's not very testable, and makes creation of comprehensive software tougher over time. Therefore, both frameworks, NestJS and Angular, supply us with dependency injection mechanism. Now, a class asks for dependencies from external sources rather than creating them by itself inside a class. The question that we should ask ourselves is, how is that even possible that either Angular or Nest know that we want to inject HTTP service at position number 1 and logger at position number 2? How is it possible? Who knows how is it possible? Please raise your hand. Okay. Nobody? Is injectable decorator a reason? Yes and no at the same time. So the decorator is going to add the metadata information to our transpiled class to make sure that this metadata information is available at the runtime, so we can take advantage of it. We can use it later on after the transpilation process. Nonetheless, injectable decorator by itself is not going to enable dependency injection feature, obviously. Being honest, the decorator could look even like this. And it's enough. So basically, a simple function which takes a one parameter, empty body, nothing inside, that's it. It's not the case anymore, though, because we can pass an options object between injectable parentheses. In Angular, we can pass provided in attribute. In Nest, we can pass a scope in order to control the scope of the provider. But basically, this is everything that you need to do in order to provide this metadata, TypeScript metadata at the runtime. So pretty much nothing. So as I said, it all boils down to the metadata, or even to be more precise, to the metadata produced by the TypeScript compiler. Basically, TypeScript is able to emit some design time serialized type metadata. Let's have a look at this class once again. So again, we have a cat service. This is what will end up in our final bundle after the transpilation process. As you can see, various things are happening around the cat service class. We've got two helper utility functions generated by the compiler, decorate and metadata. They are usually located at the beginning of the file because they are basically generated by the compiler, right? And they are doing some usual things underneath, like checking whether the reflect object is available on the global scope, and depending on that, they will assign the metadata in a different way, right? Depending on the environment. However, the most important here is actually this part. So the design param type is a TypeScript metadata key used for parameter type metadata. So this is a constant string value that you will see in your bundle after the TypeScript compilation process. And regardless of whether this is a constructor or a normal method, right, inside a class, we will always use the same key, so design param types, right? This is equal for both constructor and every method. Second argument is an array that contains references to classes that are needed in this particular context. So we could say that this metadata was kind of extracted from the constructor at compile time, right? So previously we had a class with injectable decorator with those types coming from TypeScript, right? And after the compilation process, we have a JS file, JavaScript file, and we still have something like this in the bundle. So we can actually refer to those types that we provided through TypeScript, right? Taking a step back to our class, we already know that this metadata, as I said, exists at the runtime. The question is, how can we take advantage of it? So TypeScript gives us a polyfill, a metadata reflection API that enables us to put some meta programming on top of JavaScript. And it's all about providing a consistent, simple, straightforward approach to reason over this metadata, so this thing that you can find in the bundle. Using metadata reflection API, we can get constructor param types if we put this design param types, this special string key, as a first parameter, and our class as a second one, right? So we have our reflect.getMetadata. It's not that visible here, as I can see. So the first parameter is design param types, this string, and the second one is actually our type, a cat service. And that's it. We can pass any class here, depending on what actually we want to reflect. And as you can see, this is what this method gonna return to us, an array of type that we can use to indicate which dependencies are needed in this actual cat service. So the reflect get metadata returned us an array which has two elements. As you can see, the order was preserved. So the first element is a reference to the HTTP service, and the second element is a logger, right? Once we have this array, it's super simple to actually combine those dependencies to instantiate this classes, and I'm gonna show you this later on. So now things become very simple. Let's imagine that we have an inquirer, let's say cat service, that needs those two dependencies. It goes to Injector. Injector asks for both dependencies by type, right? Because we have this array, so we have those types, which is pretty simple. And the container is a simple map, a simple collection, in which key is a type, so in our case it might be HTTP service, the reference to the type, and the value is an instance of this type, so new HTTP service that we can then share among different providers. And it obviously can also be undefined or null value if it wasn't resolved yet, right? But obviously this is just a simplification, because like presentation at a higher level, because Angular and Nest have to do some heavy lifting underneath, like handling circular dependencies, asynchronous providers. But basically, this is how the dependency injection mechanism looks at a higher level. All right, let's have a look at how the frameworks deal with the TypeScript design time metadata. So Nest is using this API directly, so there is nothing to explain. It's the same as in the normal TypeScript compilation. We don't have any post-processing. We don't have a Nest compiler. We are basically compiling files from TypeScript to JavaScript, and that's it. We are using this API in order to get your metadata at the runtime and resolve your dependencies. If you dive into the files compiled by the Angular compiler, and I'm thinking about services right now, providers, you will see something like this. It's still the same output with one small difference. Both utility functions, so this decorate and metadata, are imported from the TS lib. So basically, they do not want to put the same functions in every file, so they have one single file in order to make the bundle as small as possible. Now, nevertheless, if we move to the ngFactory file created by of any Angular component, we'll see that dependencies are represented in a slightly different way. So this is an instruction generated by the Angular 7 compiler. We have a home page component here and two constructor dependencies. So change detector ref and the router, right? So this looks actually slightly different than what I've shown a few slides ago. So as you can see, Angular performs some post-processing. Like Angular compiler performs some post-processing, which no longer uses this design param types key directly for a few reasons, actually. Most importantly, because of the performance, right? So they do not have to ship the whole reflect metadata library and all those polyfills, and they do not have to reflect this metadata and then process it. They basically post-process after the compilation process, and then they can easily just instantiate the component. In the next Ivy renderer, on the other hand, we don't have legacy ngFactories anymore. These represented as additional files close to the original files, right? Instead, this is what the compiler will produce us. Here you can see two dependencies, the same dependencies as before. Change detector ref and router. We are using a directive inject function here. And these dependencies have to be eventually injected into the application component. So as you can see, compiler hard codes those dependencies inside a factory function. And then this is fairly simple, right? We just have to call this function in order to create an instance of the component. Reflect metadata is not needed anymore once again. So it would be too good if everything was so simple. So it's not, because there are problems down the road that we may face very often. First of all, let's talk about interfaces. This is our previous example, so our famous cat service class. We are going to switch from HTTP service to iHTTP service interface, so from class to an interface. And regardless of the naming convention, I personally do not use I before every interface name, but I use iHTTP service here to clearly indicate that this is actually an interface, not a class anymore. Now let's reflect our constructor metadata once again. And it turns out that we have an object. Instead of iHTTP service, we've got a regular object type. And this type does not bring any value, right? If we have multiple interfaces in the constructor, we will have multiple objects, and all of them will be equal. So how can we distinguish that this interface is actually different than this interface? Where should I inject iHTTP service? It's impossible, and the reason is that interfaces do not exist in the vanilla JavaScript, so Typescript is not able to provide us with useful information about interfaces so far. And since we cannot distinguish them, we cannot use interfaces in both Angular and NestJS for dependency injection purposes. What would be the potential solution for this problem? The first one would be Typescript compiler at some point would have to provide some additional metadata about interfaces. This is not the case right now. We don't have any metadata about interfaces, so we cannot use them. The problem here is that how can we represent the interface in the JavaScript, vanilla JavaScript bundle? As a string, as a constant string, as a symbol? We don't know. So there is no solution for now. The second available potential solution would be to use ASD, abstract syntax tree, provide a plugin for Typescript compiler, and just enhance Typescript compiler with this metadata. So extract this information, put it somewhere behind a dedicated key, and then use it at the runtime. Another difficulty, generics. Again, let's have a look at our cat service class. We'll change the second dependency to our data source, to repository class. So instead of logger, now we'll have a cats repository, our abstraction over SQL database, let's say. So now we have a repository class. This is a generic class, right? Let's say coming from some ORM, like type ORM. And specialization here is a cat entity. And the cat entity may have like identifier, the name, the age, whatever. Let's dive into this metadata stuff once again. And you can see that we lose knowledge about specialization. Right now, reflect get metadata will return us an array. The first element will be, again, HTTP service. But the second one will be just repository. What about cat? What if we have multiple repositories in one single class? How can I actually distinguish that I want to inject cat repository at position number 2 and user repository at position number 3. It's impossible, and that's the problem. What's the potential solution? Again, the same as before. So TypeScript compiler at some point would have to provide some metadata about generics, which is not the case right now. Or we can write our own plugin for TypeScript compiler to leave this metadata so we can use it at the runtime. But right now it's impossible, and this is why you cannot use generic for dependency injection purposes in both Angular and Nest. And the last difficulty that I want to cover today is our circular dependencies. So let's say that we have a cat service, which right now depends on doc service for some reason, and we have a doc service which also depends on, but in this case, on a cat service, right? So we can clearly see we have a circular dependencies. Cat service needs doc service, and doc service needs a cat service. Let's reflect our metadata once again. And the problem here, as you can see, is that the metadata is now equal to an array with a one element, and this element is undefined. What's the reason, right? So the problem is that one class always have to be defined first in JavaScript because classes are actually functions. And thus the second one will be presented as undefined, right? It's an infinite circle. What's the potential solution for that? So in order to solve this problem, both Angular and Nest provide a helper function called forward reference, right? We are probably familiar with this function. We can put it inside the inject decorator inside the parentheses. So forward reference creates an indirect reference that framework can resolve later on. So the question that we should ask ourselves is how complicated the function reference, forward reference is inside. Well, it's super simple. So it's a function that stores the function behind a dedicated key. So as you can see, we are taking a one parameter here. Forward reference is available in both Angular and Nest, and the API, the interface is the same. It takes a one function, it saves this function under the dedicated key, and then what framework has to do, we just have to call this function, right? Once we call this function, we have a reference to the type. So let's have a look once again. Forward reference returns a reference to the doc service. The doc service is undefined inside the metadata. So if it's undefined, I can call this function to get the return type, and the return type will be a doc service, so I can actually interact with this type. I don't have undefined anymore, right? This is why we need it. So as I said, we can then just use this dedicated key, which is, in this case, just __ forward ref, call this function, and get the type. Then that's it. All right, we know how the metadata is being handled by the TypeScript by Angular and Nest. Let's talk about injector trees now. Both Angular and Nest dependency injection system are hierarchical. Whilst Angular has a platform, ng module level, and component level injector called element injectors, Nest has only one type of injector called module level injector. Let's have a look at the Angular structure. When Angular creates a component C, so this one in the right corner, which needs a C provider, it will firstly look up component's own injector. If the component injector likes the provider, right, it passes the request up to its parent component's injector. If that injector cannot satisfy the requests keep bubbling up until Angular finds an injector that can handle this request. And eventually it will hit the global scope, so pretty much everything registered with this provided in the root, right? So if we do not override a provider at some level at component A, component B, or provided directly within the component C, we'll use this global scope, so provided in root. Let's move to the injectors in NestJS now. As I said a few slides earlier, Nest has only module level injectors because we don't have components. Generally, modules form a graph data structure. All relations might be either bidirectional or unidirectional. Just to ensure that everyone is on the same page, graph is a data structure in which we have a set of objects connected by links, in which those objects are called vertices and those links are called edges. So taking a step back to our visualization, it's actually a directed graph structure in which each vertex represents a single module. It leads us to a conclusion that each module is actually a singleton, which is partially true, but it's not always the case, right? In Angular, we have this module with providers, so we can dynamically configure the module, and similarly in Nest, we have dynamic module, so depending on different options object, we can create a different module. Anyway, each module has its own injector. Also, each module has its own API, which acts like a facade. In Angular, exports array is being used to export like declarations, pipes, components, and so on and so forth. In Nest, on the other hand, we are using exports to define the public API in terms of providers, because every provider is isolated by default inside a module. So in order to use a provider outside of the module, you have to explicitly export it and thus make it as a part of the public API. So when Nest is trying to resolve your dependency, it will firstly look up a provider within a one single module. Then it will bubble up to the imported module. So as in this case, if we cannot find a provider inside the application module, we'll try looking for this provider in all those flat list of imported modules. So authentication module, users module, and block module in this case. Even if a provider exists in one of these modules, Nest would not be able to use it unless those providers are being explicitly exported, right? So if we define something, but we will not export it, we won't be able to use it. Additionally, Nest also allows you overriding providers at different levels. For instance, if both these two gold injectors contain provider registered with the same token, Nest will always use this provider, which has been defined closer to the inquirer. What does it mean? Let's say that I have an application service inside the application module. This application service is looking for user service. User service will be very likely defined inside the user's module, right? But if I want to override this user service only inside the application module, for instance, for testing purposes, right? In the end-to-end test or unit test, whatever, you want to inject some specific instance. You don't want to actually call the real database, but instead you would like to use a mock database. Then you can override it at any level. And then Nest will use this one closer to the inquirer, which means that if we override it inside the application module, this application service will use this one defined in the same scope, within the same scope, so inside the application module. Even though Nest is very strict regarding isolation levels, there is still a way to create a sort of global scope, which would work almost equivalently as in Angular. Right? In Angular, pretty much everything is globally scoped unless we register it inside a lazy module. Then it's going to create another injector, and so on and so forth. In Nest, as I said, everything is isolated inside modules, but there is still a way to create some kind of global scope that will behave very, very similar. If you change your module, for instance, core module, this one located at the left corner, to a global one, which actually boils down to adding a one single decorator called add_global, and that's it. So it's pretty simple. Nest will create virtual edges to this module from each existing module, like implicitly. Nevertheless, even global modules have to explicitly export things, right? If global module has something that we want to share across different modules, we have to define, we have to put it inside the exports array and make it as a part of the public API of the module's facade. So before end of the talk, I would like to spread a few words about things that are pretty new in Nest, since they heavily concern this talk, since they heavily concern dependency injection system. And this is something that I would say is only present in NestJS because it's not required in Angular. So far, in Nest, everything has been shared across incoming requests. Generally speaking, each provider behaves like a singleton between incoming HTTP request or microservice request, depending on what kind of system we are actually building. So if we have, let's say, user service, each request would obtain the same instance of this class, right? One provider, every request would share the same singleton. Lower memory consumption, and we do not have to actually create instances for every request exclusively. It might be strange for people coming from Java or C# world, right? Where we mostly have a thread pool, and every request is being processed by the different thread. Every request is being processed by the different thread, and thus we are primarily trying to avoid shared state between threads, right? Node.js has a different execution model, though, so we can use different concepts. So this is pretty normal in Node.js ecosystem. We are sharing things. Still, there are some very specific cases, particular cases, when you might want to use some request scope providers take advantage of something that is only for this request and should not be shared among other incoming HTTP requests. For example, in GraphQL, when you want to hold some cache, some local cache for one particular request, or maybe you want to connect to different databases depending on some request information, right? Just a typical multi-tenant system, right? This request should connect to this database, this request should connect to another database. From Nest 6, you are able to explicitly set the scope of the provider, which is super simple. Basically, you have to pass an object between injectable parentheses, scope, and use an enumerator, which is a scope enumerator, and it has 3 different values. One of them is a request. So request scope providers and all classes that depends on it, right, implicitly, will be automatically created on each incoming request and garbage collected right after the response. And this abstraction is very powerful because we actually do not have to care about it. The framework will take care of everything underneath. Angular obviously does not need this feature, right? But in server-side world, in the backend development, this is pretty useful. Additionally, we have added transient scope, which means that a new instance of the provider will be created every time when someone asks for it. Take a look at the visualization. Like normally, provider A would be shared among provider B, C, and D. However, in this case, every following provider, again B, C, and D, will get a newly created exclusive instance of I provider, right? So we have 3 instances of provider A, and it's gonna be exclusively created for every request, right? And transient scope should be actually familiar for people coming from C# world. And making a provider a transient scope is super simple. Basically, you have to pass an options object again. This options object has one single property, which is a scope property. We have to use an enumerator, and that's it. Before the end of this talk, I would like to say that Nest is open sourced, meaning that we are totally driven by the community of developers. And therefore, I encourage everyone who shares similar ideas, who loves Angular, who loves Node.js, to join this little revolution. We have lots of issues. We have lots of things that we want to provide in the future. So we are looking for contributors. We are looking for people that would love to be a part of this group. And also, if you're looking for consulting, let us know. Visit the website, send us a message. Let's talk. Thank you for attention. Thank you for having me.